Binder jetting. Binder jetting is an additive manufacturing process in which a layer of powder is spread on a table, and wherever the material is required, in that region a binder is dropped so that it will bind the particles, powder particles, and then on top of that another layer of powder is spread, again binder is dropped. In this way we are going to get the bulk of material in which the binder is holding the powder particles. So what are the elements present in it? So you are having the build platform and you are having the powder stock. Then initially the build platform will be at the topmost position. The powder platform will be at the bottommost position. Then the build platform is going to move down by one layer thickness. The powder roller is going to pick the powder material from here. It is going to move forward, spreading the powder on top of the build platform for one layer thickness. You are having the liquid binder source. Then you are having the print head. Now the print head will drop the binder wherever the material is needed in that particular layer. In the regions where the material is not required, the print head is not going to allow the droplets of the binder to fall. So in this way one layer is produced. Then the build platform is going to move down by one layer thickness. The powder roller is going to again spread the powder on top of the build platform for one layer thickness. Again the print head is going to put the binder wherever it is required. Now the question is whether support structures are needed. In the truest sense, in the binder jetting process, there is no need of any support structures, because while we are adding the binder to the top layer, below the top layer you are having the previous layer, which is the powder, which is not going to move anywhere. So no material is going to fall down because of the gravity. So basically here in the binder jetting process, no support structures are needed. The powder which is present in the build platform will act as a support for the next layer. So the entire component can be built without the need for any support structures. So once the component is completely manufactured, the component is taken out of the build platform. Then maybe a compressed air or wire brush is used to remove the loose powder particles very carefully. We say carefully because the strength of the component is dependent on the binder what we are using. So the component strength may not be very high. So in this process we can use even metal powders, we can use ceramic powders, or we can use some metallic powders, ceramic powders, or we can use sand also in this process. If you are using sand, then it is like creating a mold or core for the foundry applications. If you are using metals, then it can be infiltrated with some other material to get a good strength components with improved properties. That is also possible. Or you can take out the component and do further sintering to improve the strength. So all these things are post-processing activities. That is, after the component is manufactured, you can do any one or all of these activities to improve the strength of the component. So whatever loose powder is there, that can be taken out, filtered or cleaned, and then it can be reused. So the wastage of powder we can say is very minimal. So advantage is there is no support structure needed, so there is no work involved for removing of the support structures, maybe for grinding or polishing to make the surfaces very smooth. So the limitation is the accuracy level, because we are using the powder particles. The size of the powders will determine the accuracy and the layer thickness that we can use. So whatever the layer thickness is there, it should be more than the powder thickness that we are using. If the layer thickness is less than the powder particle thickness, then this process may not be giving very good components after the end of the manufacturing process. So this is the important thing to remember in case of the binder jetting process. So we'll see a couple of videos to understand the process. So in this particular video, the binder jetting process is used to create molds and the cores for the manufacture of the cylinder block in the casting process. So whenever we say the cylinder block, the accuracy requirements are very high because you are having the cooling channels and other things. So by using the additive manufacturing process, we are going to get very accurate molds and cores so that the component also will have very good tolerances. So this is the spreading of the sand here. This is the print head which is dropping the binders. So there will be several nozzles to improve the productivity, otherwise the process will become very slow. So once the printing is completed, the molds and cores are taken out. You are doing the brushing to remove the loose particles. You can see the complexity of the molds and cores that can be manufactured in this process. So you can assemble them. Since the accuracy of these particular molds and cores are very high, whatever component you are producing, its accuracy and dimensional tolerances also is going to be very high. So this is a conventional foundry activity that is going to happen. So cast iron, you are pouring the metal. So the casting. So that is a typical example of a binder jetting process for creation of the molds and the cores, where the raw material is in the form of a powder, that is a sand. So the binder jetting process can also be applied for metals. So here it is being used for production of a particular filter. So this is a filter that has to be manufactured. So this is a print head. This is the table on which the component is being manufactured. So the layers are cured by using some infrared rays. Because it is a metal powder, we require much better strength. So we are using additional heating, which may not always be necessary. Once the printing is done, the component is taken out. So to improve the strength, we can do the sintering. The binder holds the powder particles together. Then carefully the products are removed because the strength of these components may not be high because the powder particles are held together by a binder. So carefully we have to separate the component and the powder. Whatever powder is left out, it can be reused. So the powder wastage will be very minimal. So in this particular example, what we are seeing, these filters are infiltrated with to improve their strength. So as you are increasing the temperature, melting of the infiltration material will happen, and they are going to enter into the pores present inside the component. So the main disadvantage of binder jetting process is the parts whatever you are producing, they will not have the full strength. You require additional treatments to improve their strength and their usability. And whatever parts we are producing, because it is in the powder form, it is not melted, so it will be having lot of porosity, so the strength also will be less. So by doing the infiltration with some other material, we can improve the overall strength of this particular products produced. So the porosity can become an advantage, or it can become a disadvantage based on how we are going to use it. In case of the molds, the porosity is going to help in improving the permeability of the mold. But if you are using for a metal, the porosity, if you are infiltrating, it is a very good thing. If you are doing sintering and binding the particles together, then also it is good. If you are not doing anything, the strength of the component will be on the lower end. So that is about the binder jetting process.